Hey, welcome back. In this video, we are looking at section 1.5, which is looking at an introduction to algebra. The biggest difference between arithmetic and algebra is the use of variables in algebra. A variable is a letter that represents a variety of different numbers. A combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as powers or roots, is called an algebraic expression. We can replace a variable that appears in an algebraic expression by a number. We are substituting the number for the variable. This process is called evaluating the expression. In order to work out expressions, we must remember the order of operations. Perform all operations with grouping symbols such as parentheses. Do any multiplication or division from left to right, and then do any addition or subtraction from left to right. And you might remember that PEMDAS, please excuse my dear Aunt Sally, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. We are not going to be looking at exponents in these examples. And notice that when we have multiplication and division, they're kind of worth the same as how I think of it. And so you're going to do them in order that they appear in the problem. Same thing with addition and subtraction. So here's an example that we have. We are evaluating each rational expression, and we're substituting 3 in for x and 6 in for y. That means anytime you see an x in the problem, it becomes 3, and anytime you see y in a problem, it becomes 6. Now notice we have 4x plus 11. 4 and x are multiplied together. When two things are touching like this without anything in between, it's understood to be multiplied together. And so we're going to have 4 times 3 plus 11. Notice the x became 3 because we're evaluating or substituting that 3 in. According to orders of operation, we have to multiply first. So 4 times 3 is 12. And so our problem simplifies a little bit to 12 plus 11. And now we can add those together, and our answer is 23. For our next example, we have 25 minus 3y. And we have the variable y, which again, we are told that we're supposed to substitute 6 in for it. So we're going to have 25 minus 3 times 6. Now, a lot of times you might see me use parentheses for multiplication. So that, again, when they're next to each other with nothing in between, it means multiply. And that way I don't get confused maybe with a time sign and a decimal point, because as you can see, my handwriting using the computer sometimes is a little bit messy trying to use this mouse pad. So we have 25, and then we have to multiply the 3 times 6, which is 18. And 25 minus 18 is 7. For C, we have 4x over y. So we have both variables that we need to plug in. And so we're going to have 4 times x, or 4 times 3 over 6. Let's simplify the numerator, or the top, and that gives us 12 over 6. And again, a fraction bar can be thought of as division. And in this case, 12 divided by 6 comes out evenly to be 2. And for D, notice we have x and y multiple times. So we will get to plug in our expression x equals 3 twice and y equals 6 twice. So we have 3x, so 3 times 3 plus 5y, so plus 5 times 6, and then plus 2, and all of that is over 4 times x or 4 times 3 minus y, so minus 6. So let's go ahead and simplify. So we know that it's multiplication and division, we're working left to right. But again, we have to simplify everything on the top and everything on the bottom before we can do that last division. So let's go ahead and simplify all our multiplication. So we have 3 times 3 for 9. We're adding to it 5 times 6, which is 30. And then we're adding 2 as well. And that is all over 4 times 3, which is 12. Subtract 6. So when we add the numerator, we get 9 plus 30 is 39, plus 2 more gives us 41. And then 12 minus 6 is 6. If we look at 6 into 41, we'll get a remainder, and we can't simplify it. So we can leave our answer as 41 over 6, or we can write it as a mixed number if you want to do that. And 6 times 6 is 36, with 5 more to get to 41. So you could also write your answer as 6 and 5, 6. Try and write that a little bit neater for you. There it goes. So those are examples of evaluating expressions. Problem solving in algebra often requires the ability to translate word phrases into algebraic expressions. The following table lists some keywords associated with the operations of addition, subtraction, multiplication, and division. So you can read through those. Sum is the answer to an addition problem. The difference is the answer to a subtraction problem. Product is the answer to a multiplication problem, and the quotient is the answer to a division problem. And then you can read all of the other words that are related to each category. Some of these you might not know what they mean, so let me just peek over here at multiplication. And triple means times 3. Squared means to the second power, and cubed means to the third power. If you have any questions on any of the other ones, don't hesitate to ask. So for this example, we're going to use those words to write algebraic expressions for each statement. And it's telling us to let the variable x represent the number. So the unknown number in each equation or expression is going to be x. So twice a number decreased by 6. Twice means we're multiplying it by 2. So 2 times the number, that's our unknown, so that's going to be x. Decreased by means subtract, and then obviously 6. So we have 2 times x. So remember, we don't have to put anything in between there, because notice, is that little piece here an x, or is that one an x? So that's why we don't put the times sign in between them. So 2x minus 6 is twice the number decreased by 6. The product of 4 and a number, product means to multiply, and the word and tells us where that multiplication is going. So we're multiplying together 4 and a number. And our number is our unknown. So again, that's going to be x. So 4 times x represents 4x. Again, we don't put that times sign in between. It's understood to be multiplication when they're touching like that. The quotient of a number and 8 increased by 2. So again, I see the word quotient tells me it's division. The word and is where my fraction bar is going to go. And so what we're going to do there is we have the quotient of a number, so x, and means over, or a fraction bar, 8. So the first part of that is going to be x over 8. And then if we finish it off, it's increased by, which means to add 2. For D, we have 9 subtracted from a number. So this one's a little bit trickier because of the wording. Subtracted from. You have to have something to be able to subtract from it. So that word from tells us that we have to switch the order. And so we're taking 9 away from something. And what that something is back here, our number, so our unknown variable x. So 9 subtracted from a number would be x minus 9. And if you put in a number in there, it makes sense. If you think of 9 subtracted from 10 is 1, so you would have to write the subtraction as 10 minus 9 to get that 1. So don't let that wording throw you off there when you have subtracted from. You know that you have to switch the order that it appears in the words. So now an equation is a statement that two algebraic expressions are equal. So an expression, it's just express yourself. There's no equal sign, where an equation has the equal sign. Solutions of an equation are values of the variable that make an equation a true statement. To determine whether a number is a solution, we'll substitute that number for the variable and evaluate each side of the equation. If the values on both sides of the equation are the same, then the number is a solution. So we're going to do some more evaluating, so plugging in those values that they tell us that the letters represent, but now we have to see whether or not it's true or not. So whether or not that number makes the statement true. So for our first example, we have 5x plus 8 equals 29, and we need to know, is 3 going to make that a true statement? Are we going to get 29 equals 29? So 5x, we know, means 5 times x, and we're plugging in 3 now. So 5x plus 8, does that equal 29? 5 times 3 is 15. So we'll rewrite this as 15 plus 8 equals 29. And when we add 15 plus 8, we get 23. So 23 equals 29 is not true. And so I always put in the little line like the no smoking signs, because 23 is not equal to 29. So this is no, it's not a solution. Our next one has parentheses in it. And remember, we're supposed to simplify parentheses before we multiply. So we're going to have 3 times whatever we get when we get the difference between y minus 2. Here, y equals 6, so we'll put 6 minus 2, and that is supposed to equal 12. So we'll leave the 3 alone, and 6 minus 2 equals 4. And so we have 3 times 4 equals 12, which is true. 3 times 4 is 12, so 12 equals 12. So yes, 6 was the solution to that equation. And now we have one where we are using fractions. So we'll have 3/4 times x, or 3/4 times 2/3. And we're adding 1/3 to that. And we need to know if that equals 5/6. So is 2/3 the solution? Well, for my fraction, I see that I have a 3 on the top and a 3 on the bottom, which leaves me 2/4. They're both even, or 2 out of 4 is 1/2. So that simplifies to 1/2. And we're adding 1/3 to see if it equals 5/6. Well, we need a common denominator, and 2 times 3 is 6, so let's turn it into 6. So this one's times 3 to get to 6. This one's times 2 to get to 6. And so 1 times 3 will be our 3, and 2 times 3 gives us our 6, plus 1 times 2 is 2, and 3 times 2 is 6. So we get 3/6 plus 2/6 equals 5/6, which is true. 5/6 equals 5/6. So earlier in this section, we translated English phrases into algebraic expressions. Now we're going to do the same, but with equations, so they'll have an equal sign. Example 4, write an equation for each of the following statements, and again, let the variable x represent the number. So the product means multiply. Word and is where we're going to put that multiplication. So the product of 6 and a number, so 6 times a number, or 6x. The word is represents our equal sign. And then we have 30. Next one, 7 less than. There's that than, so it means we have to switch order. So we're subtracting 7 from something. And what we're subtracting that from is 3 times the number, so 3 multiplied by a number, 3 times x, or 3x. Gives is where our equal sign goes, and that equals 17. An equation that has variables representing some sort of real-life example is called a formula. These formulas are ones you may already know, and a variable is chosen to represent specific things. For example, converting Celsius temperature, which is using C, into Fahrenheit temperature, F, can be accomplished by Fahrenheit equals 1.8 times the Celsius plus 32. So F equals 1.8 plus 32. So if we're going to use that equation, we can figure out the Fahrenheit for 10 degrees Celsius. So 10 is our Celsius, so that's going to go where the C equals. So F equals 1.8 times C, which again, we're told that that's 10 degrees. And then we're adding 32 to it. So the Fahrenheit equals 18. We multiply 1.8 times 10 plus 32. So 10 degrees Celsius is equal to 50 degrees Fahrenheit. So again, we're just substituting like we have been. So now it's time for you to practice the things that we just talked about. If you have any questions while you do the practice problems on pages 26 and 27 and a few on 28, please don't hesitate to send me an email. Otherwise, I'll see you next time.